Good morning. It's indeed a privilege and joy to be with you all to share some of our experiences with in generation planning with large-scale renewables into the grid. And I will be briefly telling you about the way that the Indian electricity sector is growing, especially in terms of renewables, and also share with you what the renewable integration involves in terms of the grid operations. And I'll be mostly dealing with the generation planning aspects and what impact it has on the other parts of conventional generation. So India has, as you all know, India has a significant potential of electricity generation from renewable energy sources. As per MNRE estimates, solar potential in India is about 745 gigawatt and wind potential in India is 103 gigawatt. And this is a map that shows what is the solar and wind potential, how it is spread across the country. And we can see that a lot of wind potential is in terms of southern part of the country, where we have west coast and east coast, where a lot of wind potential is situated, and solar potential we have highest in Rajasthan, and like we have spread across the country. And this is the way the potential is distributed over the country. And this is the All India installed capacity as on 31st March 2017. We can see that a large part of our Indian power sector constitutes coal-based capacity, which is almost about 59%, and then renewables also is about 17% as of March. And we see the development of renewable energy in India, like it started with very small, as the initial introductions we have heard that it started mostly in Tamil Nadu, the wind, and it proceeded as 31st March 2012, it has really increased quite a bit. And if we see the bifurcation of the renewable capacity in India, we have a large chunk of it from wind power, which is about 32 gigawatt. And then over the last few years, maybe 3-4 years, the solar also has grown quite a bit, and it is about now 12 gigawatt, that is about 21% of the capacity. And then we have some biomass and waste power, that is about 8 gigawatt, and hydro, small hydro, which is about 4 gigawatt. And this growth of renewables in India has seen because of various initiatives by the Government of India. We see that with the Electricity Act in 2003, the RPO obligation, renewable purchase obligation, has come into picture, and then the various initiatives by governments, SERC and CERC, and the Jawaharlal Nehru Solar Mission that has started in 2010 has helped the growth of renewables in the country. And we all know that after very recently the growth of renewables has seen a spurt because of the initiative that 175 gigawatt by 2022 that has been announced by the Prime Minister. And that 175 gigawatt, most of it is 100 gigawatt is from solar, 60 gigawatt is from wind, and biomass 10, and small hydro 5. And this is the projected growth over the years up to 21-22. And then if we see the target, as just now I said, a large chunk of it is from solar. And the distribution of renewable capacity in mostly a few states, the RE-rich states, and this slide shows how it is distributed over the states, and we can see that Tamil Nadu has a huge share of 12%, and then Maharashtra, and then Andhra Pradesh, it goes on like that. And generation profile, when you see the renewables, the generation profile of the renewables is very important, because renewable energy sources derive energy from natural sources, and so their availability may be highly variable. So these generation sources are generally called variable renewable energy sources. Generation from VRE cannot be scheduled with the same accuracy as that from the conventional sources. The variability occurring is both diurnal and seasonal, as in the case of generation from solar plants. The other reason for variation is attributed to the uncertainty associated with natural phenomena like sudden movement of clouds, etc. Coming to solar energy generation involves the use of sun's energy to provide electricity via solar photovoltaic and concentrated solar power (CSP) systems. And the amount of energy generated produced directly depends on the sunshine intensity. Thus, the output varies both seasonally and daily. Also, there are short-term variations due to weather conditions like monsoon and clouds, etc. Normally, generation from solar gradually increases after dawn and reaches maximum around noon, and then gradually decreases and becomes zero. And this But yeah, the curve will not be as smooth as predicted here. Like it will be varying quite a bit as seen here. Like if you integrate some solar plants together, it will come a bit smooth. So the uncertainty associated with the output of a single PV system can be smoothened out into two ways: aggregating a large number of PV systems and aggregating the output of different PV systems scattered at dispersed geographic locations. As the number of PV plants increases, their normalized aggregate output becomes smoother. And coming to wind turbine output is directly proportional to the cube of the wind speed. Wind power becomes unavailable at both very low and very high speed. This is different from the solar, where changes occur rapidly and variation may be from second to second due to cloud cover. So this is a typical wind generation curve of a day. It is mostly seasonal, wind is. And we have tried to project the Tamil Nadu typical daily wind generation curve month-wise. And we can see that certain months it's very low, almost nil, but certain months it will be very high. And this is a pattern in Gujarat, because these are the two states which has a large potential of wind and solar, wind especially. So from the, because as renewables cannot be dispatched as the conventional sources, we have to take into account the pattern of this renewable generation into account when we do the generation planning in general. From the projected hourly All India demand profile and the All India hourly renewable generation pattern, for the year 21-22 we worked out the net load profile, that is taking out the renewable generation from the load, from the projected load. So All India net load profile thus obtained is generally known as a duck curve owing to its shape. And this is the typical, it's for a peak day in 21-22, where you can see the dip in the net load curve. The down curve shows the net load, whereas if you see the upper curve, it is the demand. So we see that because of the huge renewables coming into picture, especially solar, there is a dip in the demand pattern of the country as a whole. So what are the major challenges? Major challenges in terms of renewables is, one is the advanced forecasting. Most of the time, the forecasting is not very accurate. Because of that, there will be, I can watch for, like, Tamil Nadu finds it very hard how to dispatch their generation because of sudden changes in wind. And because of advanced forecasting is one of the major challenge. And as we have seen in the previous curve, there is an increased ramping requirement. Suddenly when the sun goes down, there's an increased ramping requirement. When the sun comes up also, ramp down is sudden, and like it is gradual, but then it is steep. And so there is a lot of ramping requirement. And then the balancing requirement, the grid balancing, and which also involves transmission system strengthening when the power is excess in certain places. And so the market design to cater to this is also a challenge. So we have done studies how to see what is the effect of this large-scale renewables on the carbon emissions. So based on the projections of capacity addition by 21-22, the estimated generation available from variable renewable energy sources, that is solar and wind, is about 274 BU. With present weighted average emission rate of 0.82 kg CO2 per kWh, estimated avoided CO2 annually will be around 225 million tons. In terms of INDCs, like for climate negotiations, India made some commitments. India's INDC commitment of 40% cumulative installed capacity from non-fossil fuels by 2030 shall be fulfilled much earlier if the pace of capacity addition of from RES is maintained as per schedule. So as per the schedule, by March 22 itself, we will reach around 47.5%, and by March 27, we will reach around 60% from non-fossil fuels. So what is the impact of this large-scale renewables on the coal-based plants? As you know that Indian power sector is dominated by coal-based generation, the impact would be largely felt by these plants. In fact, the study results indicate that the generation from VRE and coal-based plants are inversely proportional, like perfectly negatively correlated. So we have done studies with different growth rates in terms of demand, and also taken alternative scenarios of renewable additions, like 125 gigawatt, what will happen if it is 125, what will happen if it is 150, what will happen if it is 175. And we see that 175 brings down the coal-based PLFs quite low as 48 to 48%. And they change. So what are the conclusions that we can arrive from this? So the share of energy generation from renewable energy sources is going to increase from 7% at present to around 20% of the total energy requirement in terms of energy by the year 22. However, the increase in generation from RE sources will lead to conventional generating plants to be more flexible to cater to the increased ramping requirements due to variability associated with RE generating sources. So this, to deal with it, like Government of India is looking at various options, like even today my chief engineer is involved with, how do we manage our gas-based capacity to see the ramping requirement, or how do we use hydro plants only for peaking and things like that. Government of India is looking at various options, and advanced forecasting techniques need to be adopted to accurately predict the output generation from renewable energy sources. And also the transmission system needs to be strengthened to evacuate renewable energy from rich RE states to other parts of the country. So these are some of the conclusions from our studies that we have conducted. Of course, from the time we have done these studies and now things have changed. We have done different studies later on, because Government of India, because of environmental norms, are planning to retire some of the old thermal plants which has which doesn't comply with the new environmental standards. So some of the coal-based capacity, almost to the tune of 20 gigawatt, has to be retired, and so that will change the scenario a bit. But overall, the scenario will continue to remain the same with this large-scale renewables into the grid. Thank you.